Let us see if this works.
Test 1, 2, 3. Guys, can you hear us?
Yeah.
Yes.
So all the jokes we already made, all the nice giveaways we announced. You didn't notice. No, we're not going to repeat anything. We're not going to say what the giveaway is, and we're not going to say that our second choice because
No, you were 10th choice today.
Yeah.
Now we explained before, usually with a new CPU launch, you expect to see Ruud here, but unfortunately you couldn't make it today. So that's why Eric is here now. So basically I tried everyone, no one was available, and in the end I had to go with Eric. So he's going to be my lovely assistant. But Intel 14 Gen, today's topic, maybe you've already read about it, maybe you've already seen some reviews. We will do some benchmarking today, so I have two systems here in front of us. One is based on the 13th Gen, one on the 14th Gen. And usually we always go for like the highest end SKU in a lineup. So you may expect to see the Core i9-14900K here, but we decided to go with the i7 this time, and that of course has to do with the changes in the different SKUs. The i9 and the i5 keep the same core count compared to the previous generation, whereas the i7 gets 4 additional E-cores compared to the 13th generation. We will go into more details about all the SKUs later, but that's why we decided to have a look and compare those two.
Yeah.
We will also do some fine-tuning later on to see out of the box. Maybe you already read about it, like power consumption can be a thing in combination with cooling as well. So we're going to do some fine-tuning, like how can you get it more efficient, still maintain the same performance, those kind of things. And also, if you're going to go down on power consumption, how much performance would you lose in certain situations. So we'll do some fine-tuning as well. In the past, we always leaned a lot towards overclocking, but nowadays CPUs are already pushed quite far to their limits. So personally, I think it's more interesting to see what you can achieve.
I think also with the energy pricing, it makes more sense to I mean, it's underclocking doesn't mean underclocking or
It's like more of undervolting we will do today.
Yeah,
Power
it's more
limiting
optimizing for trying to keep the same performance but save some power.
Yeah, indeed. Skeet says E-cores are only for benchmarks. I disagree. Especially for productivity workloads, E-cores will help you a lot. More cores will give you a lot more rendering performance. Later on we will also do some Cinebench on both systems. There you will also see what the difference is if you have 4 additional E-cores. For gaming, I totally agree it doesn't add too much, but for productivity it definitely makes a difference. So it also depends on what you want. Like if you want to build a completely gaming system, you don't care about productivity, then for example the Core i9 doesn't bring you too much over a Core i7 or even the Core i5. If you do a lot of productivity, cores help a lot.
Yeah.
Yes.
That's what Nicholas is saying as well. I like to see how much you can bring down the power. To 0.
No, but I think you can definitely achieve quite a bit with fiddling around. If you're comfortable with it, of course. Within the BIOS we have several options. We will also highlight a few. We will show some memory optimization as well, how basically a simple setting can give you some more memory performance without even touching the frequency. So there's a lot of stuff you can fine-tune, and that's also how you can get the most of this generation. Eric, let's maybe take a look at the lineup from Intel. We can talk a little bit about compatibility as well with our motherboards.
So as always, Intel launched. Oh, my audio again. They launched several CPUs. I hope everything is working. Let me double check. Yeah. Okay. So they released the i9, the i7 and the i5, and like Michiel already said, actually, they're like speed bumps based on the old technology, on the old architecture, and only the i7 got 4 extra E-cores, and that's why we picked that one.
If you already own an LGA 1700 MSI motherboard, you can also put in a 14th Gen CPU, but also the other way around. We recently launched our Z790 Max motherboards, and if you want to use that with the previous generation, that's also compatible. Of course, in certain situations, you need to flash your BIOS, but even for the 600 series, our first generation LGA1700 motherboards, you can already find the BIOS that is compatible with the new 14th generation processors.
Yeah, I think we're already shipping them with a compatible BIOS like June, July somewhere.
Yeah, for the 700 series, yes.
Yeah.
So maybe if you go to the next slide, you can also see how you can identify if you have a 700 series motherboard, if it already supports the 14th generation out of the box, because then there is a sticker on there. It says next gen CPU ready from now on. I believe we will replace the stickers with 14th gen CPU ready.
But that will still take some time before they're in the market.
In case you bought a 700 series and it doesn't have that sticker, then you can of course still use it in combination with the 14th gen, but you need to flash your BIOS first. You can do that with an older CPU, but also most of our motherboards of course have a flash BIOS button. Then you can just connect your power supply, plug in the USB drive in the correct USB port, press the button and flash the BIOS through there. So that way you don't need an older CPU in order to flash your BIOS to make it ready for the 14th generation. So compatibility always is in both ways, so both for older motherboards with newer CPUs, newer motherboards with older CPUs is all cross-compatible. Just in certain situations you need to update your BIOS.
Yeah, and compatible doesn't mean that you can take the new 14900K and put it on the entry-level mainboard. I mean, you need to have a little bit of sense. So
yeah, like technically you can put it like on an H610 motherboard, but of course the VRM on most H610 motherboards is way more limited than on a Z690 or Z790. Yeah. But for example, if you have a good Z690 or B650 motherboard, you can definitely also run this newer generation of processors.
Oh, I still have my jacket here.
In case you're getting cold, then...
yeah, indeed.
Pirquito says, my MSI Z690 Carbon with i7-14700K. Yes, definitely possible. If you flash your BIOS, BIOS is already available for this 14th generation. It is fully compatible. Of course, the feature set may differ a little bit. So if you have a Z790 board compared to a Z690, you will, for example, get some more Gen 4 lanes for multiple M.2 slots. But in terms of CPU performance, there will be no difference if you use it on a Z690 or a Z790. NRT is asking, but can it run a Pentium 3? Maybe with a hammer if you can get it in, but no warranty for that one. The
slot, what was it called? Slot 1? Yeah, AMD was slot A and this was slot 1.
Indeed.
Yeah.
Arun 5D is asking, is this a desktop or a notebook processor? These are desktop processors that Intel launched. So the 14th generation Intel Core desktop processors.
Most notebooks are BGA, meaning they're soldered on the mainboard. Yeah. And these are LGA, means they have a socket and you can replace them, upgrade them, downgrade them, or whatever you want. So let's talk a little bit about CPUs. So Intel released several new CPUs, 14900K, the 14900KF, and the KF means without graphics and K means overclockable. And as you can see, compared to the previous generation, let's have a look at the top, the 14900K versus the 3900K. You see that the clock speeds, you know, they improved a little bit. 5.8, can I do like this? Well, it's, yeah, you can see. 5.8 to 6, 5.7 to 5.8, 4.9 to 4.4 gigahertz. Sorry, 4.3 to 4.4. So really small differences.
Eric, can you put the chat side by side so it doesn't block anything?
Yeah, I can.
Because I see a question from... LDG is asking, does KF bring any increase of performance being the video integration is disabled? Is this a thing? No, they basically compare identical. Also, you can switch off the integrated graphics on the K SKU, basically making it a KF.
I mean, you would think so, because VGA is disabled. I would say it's inside the GPU. They didn't take it out, they just...
in the CPU, you mean?
Sorry, no, the GPU.
The integrated graphics is inside the CPU.
It's inside the CPU, yes. Yeah. What did I say?
Inside the GPU.
Yeah, that's why I was like 10 choice, right? Anyway, so, but it's not running, so it's not generating any heat, because most people will use discrete graphics. Otherwise, the logic will be, okay, it's not there, so it generates less heat, so you have more headroom to put clocks up.
It may make a difference, but I haven't tested this if you, for example, use Intel QuickSync technology. So then basically you're using the integrated graphics, not for graphics
That's for,
output, but for
converting
example,
videos.
For converting videos, then it could make a difference. I haven't tested it, but I can. It would make sense if it consumes power, generates a bit of heat there, and that can have a little bit of influence on your boost speeds. That could be a difference. But usually if you plug in the VGA, then it will use that graphics by default. Basically, the iGPU isn't doing anything, so should it make a difference in terms of performance?
The interesting thing is here that you save about, what is it, like $30? 20?
Yeah, I think 25.
$25, yeah. And yeah, I mean, if you're buying a 4900K or KF CPU, you're not going to use integrated graphics anyway. You probably use discrete graphics, NVIDIA or AMD VGA card.
Yeah.
And then,
but
you know, you save
why
some money.
some people still want to have it is, for example, if you want to do debugging, if you think your VGA card may be broken or anything, then you can switch over to your integrated graphics and see if that's indeed the issue. Yeah. And also, if in case you have to RMA your graphics card, then at least you can still use your computer without having to use a different graphics card in the meanwhile.
But not
of course, gaming will be a challenge because it still has the Ultra HD 770 graphics, so the graphics have not changed in terms of generation from the 12th to the 13th or the 14th generation Intel, but it is clocked slightly higher, so it will be a little bit faster, but these are not meant for gaming. Like for a bit of browsing, watching videos, stuff like that, it's perfectly capable, but for gaming, yeah, use discrete graphics cards for these CPUs.
Then we go to the i7 segment, same story here. Two new CPUs, 4700K and 4700KF. So clock speeds are the same. So actually, I should not say same story here. Clock speeds.
No, clock speeds are a bit higher.
Yeah, indeed. So yeah, same story. Clock speeds have got a little bump. However, here is interesting because you get extra E-cores. So instead of 8 performance cores plus 8 energy efficient core.
The chat is not scrolling, by the way. It is stuck.
You are always complaining about chat.
Yeah, there we go.
Yeah. Okay.
Yes.
So you get 4 more efficiency cores, and this will, I mean, it will not help you in single threaded performance. It will help you, however, in multi-threaded performance. So Cinebench.
Yeah. So like Cinebench multi-threaded, you will see later on. That's also what we will compare today. We have a 13700K system on this side. We have 14700K system on this side. Other than that, they're not 100% identical, but we tried to make them as close as we could to each other because we didn't have identical samples. So for example, both are running an RTX 4090, but they're different versions because we didn't have two the same ones. But we tried to make them as close as possible. Also, mostly we will do some CPU testing, not really GPU in this situation. But yeah, later on you will see where those cores make a difference. So E-cores, they're not only for benchmarks, they're in certain situations definitely give you more performance. Michael is asking, has MSI pushed BIOS updates for Z690 and Z790 for 14 Gen? Yes, they're already available.
Yeah, for some months.
Yeah, so if you check on our website, look up your model. If you go to the support and BIOS section, if you download the latest BIOS version there, you will have support for the 14th generation.
And pushed is maybe the wrong term because you actually need to take action. You need to go to our website, download it, and flash it.
Yeah.
It's not that you automatically get a new BIOS update. It's not like your iPhone.
No, not like an over-the-air update or something. Yeah. It's indeed, you have to flash it yourself.
It's also too dangerous because our motto is always, if you don't have any issues, don't update the BIOS.
Depends a bit. Like sometimes BIOSes bring certain new features that can be really interesting. I know, for example, earlier we saw with AMD, they introduced Curve Optimizer in the newer BIOS versions. So those kind of updates, I can see why you still want to update even though you don't have any issues.
True.
But if there is no like real new feature that you want to use, then if it works fine, stick to your BIOS.
Yeah. Okay, i5 CPUs. Again, 2 SKUs, K, KF, and again, bit higher clock speeds.
Yeah.
TDP stays for everything the same, but as we already know, TDP is just a number. I mean, the actual power use can be higher. And later we will benchmark this.
Adorian Seeker says also biosecurity updates. Also a good point. In the past, there have been some issues, for example, with Meltdown and Spectre, those kind of things, and then definitely makes a difference there.
But normally those BIOS make it slower, right?
Depends on what needs to be fixed. It very much depends on what the issue is. If it's a big issue, that can be the conclusion, yes.
The KLF. Good sound, good music.
Okay, and then i5. i5 is basically, it's basically the same story as with the i9. So again, a speed bump, couple of 100 megahertz higher, but the same core count compared to the 13th generation. 13th generation, however, was a bit higher than the 12th generation. But here you will see a little bit of a speed bump, both in single-threaded and multi-threaded, whereas for the i7 you see a little speed bump for single-threaded and a bigger speed bump for multi-threaded. And also the price, the same again, like with the i7 and the i9. The MSRPs for all models are the same as in the 13th generation. Of course, it depends a bit on what the market does as well. Now you may see good deals pop up for the 13th generation, and that can definitely also be very interesting because, especially for like the i5 and the i9, of course, the 14th generation is a couple of 100 megahertz faster, but you still, with the 13th, get the same core count. With the i7, of course, that's a little bit of a different story.
Do you guys think integrated graphics is enough for light gaming? Yeah, for couch gaming, it's perfect. I mean, as long as it doesn't use ray tracing or other nice graphics. It depends a bit
on what kind of games you want to play as well. Like integrated graphics, if you run like very light games, it's fine. But if you want to play any AAA title, even for couch gaming, that's going to be a challenge.
Yeah. Well, like, couch gaming, the party games.
Yeah.
Those kind of games. Yeah, I know some people are couch gaming other games indeed. Yeah.
You mean like stick fight and stuff that we played before? And
yeah, but also like indeed, what is it? Overcooked, Moving Out, those kind of games. Yeah, indeed, no Cyberpunk.
Yeah, and also it depends very much on your resolution. If you want to do it on 4K, then it may still be a challenge, of course.
Yeah.
Also, if you want to do some cloud gaming, then of course this can also be fine.
So another question. Need to scroll up for a moment. So this mouse. Edwin K. What must be water cooled and what cooled with a fan? I would say, I'm not sure if Mike agrees, but i7 and i9 I would go for a liquid cooler.
Yes.
And i5 depends on your situation. And that's because these CPUs, we already have this for several years, but the architecture means that they will push to the maximum turbo they can achieve, and that's done by cooling.
But also, not every liquid cooler and not every air cooler is the same.
True.
So, for example, for an i5, because it's still, like the i5K still have quite many cores. It's 6P cores and 8E cores, so it's still a 14-core processor. And if you're going to use that for like heavy CPU workloads, for example, if you want to do some rendering on them, then I would advise to go even for the i5 with maybe a 240mm liquid cooler or one of those big tower air coolers. Of course, you can use it with a smaller air cooler as well, but then you may see that you're limiting performance a bit because of thermal throttling, for example. It's not that you will destroy your CPU right away, but you may lose out on some performance there. Yeah. For gaming, however, you wouldn't see much of a difference. Because with gaming, usually the workload in your CPU is a lot lower. So also there, if you have like a smaller 120mm air cooler, you will still be fine. Of course, you can air cool all of them, but if you're going to do like CPU intensive workloads on the i7 and i9 with a relatively simple air cooler, that will be very, very challenging.
Yeah. The question on Twitch, but also the same on TikTok. Is it an MSI insurance or repair center where you can go with your mainboard if your PSU turns off during updating your BIOS? First of all, I think that you destroy your BIOS, it's not a, the chance is not big, because it will first flash the boot block, which is a small part, and then it flash actually the content of the BIOS update. If the boot block is intact, you can still boot it and flash it. Even if it's broken, you can contact our repair centers. They have special tools, which like an adding card, like in the past, you remember TL60 or something?
Mm-hmm.
or I don't know how the cards are called. Anyway, they have names. They can still flash it. And on, I don't want to say most, but on a lot of mid to higher end mainboards, you still have BIOS flashback, which also might work, right, Mike?
Yeah, with the flash BIOS button, indeed, you can often still have a successful BIOS flash, even if one failed, for example.
Yeah. So if you have a problem, no worries, it can be fixed. And if it cannot be fixed, we will tell you.
Arjen is saying overclocking is not safe. How should I do it safely? If overclocking is safe or not very much depends on if you know what you're doing or not. Overclocking by itself is usually not that risky, but increasing the voltage can be. Because with a higher voltage, you can damage your CPU.
You know, just take it small, step by step, and it doesn't matter if your system crashes. It just means that you went too far or your cooling is not enough. And you know, if you increase the speed or the base clock or even the voltages, step by step, you know, make sure it's stable. And I think overclocking, of course, it can still be interesting, but I think underclocking or undervolting.
The thing with these
way more interesting in the last generation CPUs.
Yeah, these generations, with all the boost technologies they have, here you already see some examples, but maybe can you go to the i9 slide again?
Yeah.
Because there you have even more boost possibilities. So you also have thermal velocity boost, for example. So basically what Intel already does with these boost functionalities is they push everything out of the chip that is in there, basically. But this, of course, comes with certain power consumption as well. And like Eric already mentioned, in these generations, it's usually more interesting to see how can I make it more efficient? How can I still maintain as much performance as possible while using less power? That's usually the more interesting thing to look at in the last generation. So that's also what we will demonstrate today.
Yeah. Let's continue, Mike, because then we can do live demos. Because I see a lot of questions about, are you going to overclock memory? We're going to talk about it. We're not actually going to overclock it live, but we're going to show you and talk about it. So let's continue, talk a little bit about our motherboards. This is our new lineup of the Max mainboards, and basically they have Wi-Fi 7. That's the biggest difference. Of course, a lot of other small details.
Yeah, some stuff is upgraded as well.
We already had a dedicated live stream about this, so if you're interested in the mainboards, I think, Mike, you have them there as well, right? I hope you have, because I dragged them from the other building to here.
But actually one we're using today, so that's the MAG Z790 Tomahawk Max Wi-Fi. That's the board we're using today for the demonstration system of the 14th gen CPU. So that one is running here with the 14700K. So that one you will see in action. The 13700K, the other test system, is running on a Z790 non-Max board, in this situation the Carbon. In our Max series, we also have some MEG and MPG models. So in the MEG segment, enthusiast segment, we have Godlike Max and Ace Max. In the MPG segment, we have Carbon Max Wi-Fi and HTI Max Wi-Fi. And then there is also one new Pro board, which is the Pro Z790-A Max Wi-Fi.
So question in chat, are the VRMs improved on the Max series? No.
No, the
First
VRMs
of all,
are the
CPU is basically the same. Secondly, in my opinion, most were already overkill.
Yes. So the improvements you will see in the feature set. So for example, Eric already mentioned Wi-Fi 7. This is a change compared to the previous generation where it was still Wi-Fi 6E. Wi-Fi 7 is still a draft version, that's important to mention here. So you will see different versions of Wi-Fi 7 in the market right now, because people are kind of guessing in what direction it's going, but we opted for like a higher end version of the Wi-Fi 7 to make sure that we meet those requirements. And basically the main thing of Wi-Fi 7 compared to Wi-Fi 6 and Wi-Fi 6E is the maximum bandwidth will be a lot higher. So also like we're based in the Netherlands, for example, and recently we can see internet speeds going up. So it used to be up to 1 gigabit per second for fiber connection recently, 5 gigabit per second indeed.
Do you know the price of that?
Sorry?
Do you know the price for 5?
No, I don't know. I don't know if it's available in my area already, actually.
I'm scared to check.
Yeah.
Probably it's very expensive.
Yeah. But there you see that now that the internet speeds go up, it can be useful also to have faster Ethernet, so the LAN port on your motherboard, but also the Wi-Fi 7. So most boards nowadays have 2.5 gigabit LAN. On Z790 Max, that's also the case for all the boards, apart from Godlike, that has both 2.5 gigabit and 10 gigabit LAN. And also all boards in the Z790 Max lineup, so also, for example, the more affordable Pro board, are equipped with Wi-Fi 7 to get those high bandwidths possible through Wi-Fi as well. Something I want to mention here is Wi-Fi 7 only available on Windows 11. Not on 10.
No, we're going to do the giveaway, Mike.
Oh, that's a good idea.
You said something like not available Windows 11?
No, Wi-Fi 7 only through Windows 11.
They need to read the manual.
Yeah, so if you run Windows 10, you cannot use that.
Yeah. So guys, check the manual. We're going to do a giveaway.
Yes.
We have some nice game to give away.
If you haven't participated yet, go to msi.com/2/insider, or if you're watching on YouTube or Twitch, you can also follow the direct link that our bot puts in the chat
so
once
first
every
winner.
5 minutes.
It's not fast, it's still refreshing. There we are.
Winners. Go to winners, go to draw.
Draw. Lucky draw. So, first winner for today. It doesn't. Okay, with loyalty bonus. Thank you. Soul Taker. Congrats. In the coming days, you will get a code for Assassin's Creed Mirage.
Congrats.
Will take you at least 20 hours to finish. Okay, Mike, back to your story about Wi-Fi 7. Okay, so Windows 11, you need it.
Yeah.
Nice. Next.
This is a new addition specifically for our Carbon Max Wi-Fi motherboard. So the Godlike and the Ace already come with Intel Thunderbolt 4 support. So that's up to 40 gigabits per second over USB Type-C. We didn't have that available on the Carbon yet, but Carbon comes with a nice add-in card in this generation that adds USB 4 through that add-in card. And it also supports both power delivery, so up to 100 watts on one port, up to 27 watts on the other port. Make sure to connect the PEG connector for that, so the additional 6-pin connector. And it has DisplayPort pass-through, and that basically means that if you plug in your graphics card to this card, so basically you link it together, you can get both the power and the DisplayPort signal over a single Type-C cable. Of course, if your monitor supports that as well. But that way you can power it and get the display signal there. So only a single cable needed. Then we made some upgrades on the M.2, and here you will most likely see the upgrade for the Edge and the Tomahawk, because they now also offer PCI Express Gen 5 on the M.2, whereas with the Z790 non-Max boards, that was only from Carbon and up, so Carbon, Ace and Godlike. The Pro model is still limited to PCI Express Gen 4. So if you want to be able to use PCI Express Gen 5, make sure to get one of the gaming models. But they now all offer PCI Express Gen 5 on at least one M.2 slot.
And you know, in the past we had a lot of people complain, I need more SATA ports, I need 8, I need 12. Well, if 7 is still not enough for you, you can always use the add-in card.
Yeah.
Or maybe even 2 on this Godlike mainboard.
Yeah, but 7 M.2 is a lot. I'm not sure if people are like especially what you saw with like hard drives and SSDs. At a certain point, people gathered so much storage, and then they upgraded, but they wanted to keep the rest that they already had. So I know people who had like 10 hard drives in their PC or something.
Yeah. And I would say nowadays a lot of things are in the cloud or online.
I would say M.2 is also still a bit too recent, so people have probably only maybe upgraded once or twice from M.2 SSDs, so maybe you have 3 now. Could have more, but I think 7 is still very, very extreme, but it is future-proof, so you can keep on upgrading and adding M.2 SSDs if you want.
Yeah. No, those are not double height. So it's not 9.
Double height? How do you mean?
Like on Mini ITX.
Ah, okay. No, they're not like stacked M.2 slots.
No.
Prince Maria is saying, can you tell me the best budget motherboard in which I have an i9 1300? I think you mean 13900 with an RTX 4090 and DDR5 RAM. It depends a bit. Is the Core i9, is it a K SKU or not? Because if it's a K SKU, then it is technically overclockable. Then the question is, do you want to be able to use that or not? If you don't want to overclock, B760 can indeed be very nice. But if you want to run an i9 in it properly, go for a higher end B760.
No, he says budget.
Yeah, but that's still for an i9 is relatively budget. But for an i9 you need a relatively strong VRM. So if you go for the stronger...
It's strange why he wants to save on the mainboard. He buys the high-end CPU, the high-end GPU, and then a cheap mainboard.
But it depends a bit. If you don't use a lot of the expansion possibilities, if you don't use many M.2 slots, if you don't want to do overclocking, then you also don't really need a Z-series chipset. So then, for example, if you have a B760 Tomahawk or Mortar, those would be able to run a Core i9 at stock. So I would go for one of those in that situation. If you want to do overclocking, you will need a Z-series by default. And then the most affordable option would be the Pro models.
How long do you want to benchmark? 1 hour or longer?
No, about 5 hours or...
No, but I mean...
No, just kidding. Yeah, I think 1 hour.
Okay, yeah, then I will control the time.
That's okay.
I'll push you sometimes. Okay, let's continue.
Yes, M.2 Shield Frozzer, screwless one we already introduced in the previous generation, but are now adding it to the Tomahawk as well. So in the previous generation was for MPG and MEG, now Tomahawk. The board we have right here has it too. Makes it very easy to install M.2 SSD, especially in combination with the easy M.2 clip. So you don't need any screwdrivers and stuff like that. Other than that, it's the same as on the Z790 non-max boards.
Question on your high-end boards, which one does not have iGPU support? That's only the Godlike.
Yeah, only Godlike.
Yeah.
And the reason for that is that for Godlike, because it's like the most extreme motherboard, we also wanted to make the CPU VRM as extreme as we possibly could. But that means we need all the space basically around the CPU socket to put V-Core VRMs. If you would put one for the iGPU as well, that would cost you one of the V-Core VRMs. So that would make the VRM for the CPU less extreme. So that's why the Godlike does not have it. If you want to use the iGPU, however, could be for example, QuickSync or those kind of things, then the Ace is the highest end board that supports the iGPU.
So Voicemod, we have a project together with Voicemod, so we integrated it in our MSI center. In, I think, 3 weeks time we will have a live stream about this, beginning November somewhere, probably the 8th or something, I don't, let me see.
95 is asking, so Ace has iGPU support? Yes, indeed, Ace does, yeah.
Yeah, 8, okay.
So then more cool, by the way. We have already demonstrated this a little bit in earlier live streams. It's
really fun.
Yeah, it's really fun. So I think that the live stream will also be a lot of fun.
You have the mainboards over there, right?
Yes, I do.
Except for this one.
Yes, Godlike I unfortunately don't have yet.
They don't trust us with expensive stuff.
No, I think they heard that you would be in today's live stream, and then they said, "Oh well, we're going to keep the Godlike for now."
Yeah. Ace has iGPU support, yes.
Yeah. So here you see Godlike. It is a 26+2 phase, so 26 phases specifically for the V-Core, the CPU. 105 amp, so this is basically the most extreme VRM design you can get nowadays. It has a lot of cooling on there, so you have the wavy fin design, you have cross heat pipes, so multiple heat pipes going through it. You have a fin stack heatsink instead of just a solid block, also to increase the surface area for more efficient cooling. A lot of storage options, 7 M.2 slots in total, Wi-Fi 7 of course, but also both 2.5 and 10 gigabit LAN, so it has 2 LAN ports. It supports Thunderbolt 4. What else do I forget? Oh, of course the M-Vision dashboard, the small LCD screen that comes with it. It's an LCD touchscreen. You can put a lot of diagnostic information on it, but you can also control, for example, like restart your system, stuff like that. But also, in case you want to use the Flash BIOS button, you can actually see the progress on the M-Vision dashboard as well. So a lot of cool stuff you can do on that one. Then let's go to the Ace, and that one. So
this Godlike is our most high-end Z790 motherboard.
It's the most extreme one.
Yeah.
It's also extended ATX, by the way. That's something to keep in mind. This will not fit in a regular ATX motherboard because extended ATX is a bit wider. And the same goes for Ace. So I can also show you what the difference is approximately. Let me turn this a little bit. There we go.
Ooh, that's dangerous what you did.
Yeah, it is. living on the edge.
Yeah.
So, for example, here you see our carbon. This is a regular ATX motherboard, and the ACE is an extended ATX. So if I stack them on top of each other, you see that the ACE is clearly wider. So it is important that if you're going for an extended ATX motherboard, you also have a case that can support this.
Colonel Strike is asking, is Unify series definitely discontinued? No, but this generation we don't have Unify, and I don't know about future plans. But that doesn't mean it's
could be that it
cancelled.
still comes. I don't know, to be honest.
And we like it as well, so we're going to push for it. So let's
Yes.
hope somebody's listening to us.
So Ace, from the top of my head, Eric, but correct me if I'm wrong, 24 times 105 amp smart power stages for
24
CPU?
plus 1 plus 2, 105 amp.
So the 1 plus 2, specifically the 1 means that there is a power stage for the integrated graphics on this one. So here you can use the iGPU if you want to, either for graphics or for stuff like QuickSync. You still have a ton of M.2, so in this case 5. This one is screwless M.2 shield frozzer. It's also dual-sided, so you get thermal pads on both sides and also heat sinks on both sides.
It would be funny if you found back one of our SSDs, right?
Yeah, I think we've already lost a couple of SSDs when we shipped them to
Yeah,
certain
we always
places.
have
and
like
SSD
SSDs below those heat sinks, and then somebody wants to borrow the board, and then a few weeks or months later we're like, hey, I'm missing
Where's
some
my
SSDs,
SSD?
where are they?
I think MSI Germany currently has an additional 2 terabyte SSD.
Yeah, it could be.
So yeah, I think very cool motherboard. A lot of RGB as well, not only in these heatsinks but also in the M.2. And that's actually interesting to show you because there is a magnetic connector. You can see it right there. So there is RGB in this heatsink in the ACE logo here, but you don't have to connect the cable. So basically you just install this and it will connect through this connector on the motherboard. So it's completely cableless for the RGB lighting as well.
Yeah.
Arjun is asking how many graphics cards does it support? Well, technically in every PCI Express slot you could put 1, so in this case 3. But I would personally recommend at the moment just go for a single graphics card. Nowadays you see that not many game developers even support either SLI on NVIDIA or Crossfire on AMD anymore.
And if you're really talking about rendering or mining, if that's still a thing, then I would really advise you other mainboards.
Yeah, there are boards with more PCI Express slots for that.
Yeah,
so I would recommend with these kind of boards, use a single graphics, especially when it's for gaming. I would recommend use a single graphics card at the moment. 4 DDR5 slots, of course. Yeah, what else? Let's have a look at the I/O. Thunderbolt, dual Thunderbolt actually. So these 2 vertically positioned ports are the 2 Thunderbolt ports. They're Type Cs. These are the mini display port inputs. So here you can also interconnect your graphic card to these inputs and get both, also the display signal over the Type C. Here you have the antenna points for the Wi-Fi 7, bunch of USB ports. You have 2 LAN ports, both in this situation are 2.5 gigabit. So Godlike comes with 2.5 and 10. This is 2 times 2.5 gigabit. Then you have a bunch of buttons here. So you have a flash BIOS button, a clear CMOS button, and an additional smart button that you can assign yourself, for example, to switch on or off the RGB lighting, or you can use it as a reset button, or you can change that in the BIOS what it does. Then there is an additional Type-C port right here. That is not a Thunderbolt port, but 10 gigabit per second USB Type-C port. Then it has...
I'm always impressed by Mike. He knows this.
Yeah, I know a lot of shit about these.
Yeah.
You also have the USB audio codec from Realtek, in this situation the ALC 4082. And this motherboard comes with Audio Boost 5 HD, and that includes an ESS DEC, for example.
Did you already talk about the 60 watt PD?
Oh yeah, that's a good point.
Yeah.
Because you have 2 front USB Type-Cs here, and one of them you can use for additional power delivery. That's also why you see this 6-pin power connector. If you connect this, you have, what was it, 60 or 65 watts?
60.
60 watts power delivery over the front USB Type-C. It is, however, important that if you want to use this, your case also needs to support this.
No.
So, for example, our new Prospect case, which is an extended ATX case, so it can fit the Ace motherboard, does support this. So you can, if you have like a notebook that supports power delivery, or if you have a Steam Deck, or if you have a smartphone that does power delivery, you can all charge them through the front USB Type-C.
The reason why your case needs support is because the cable is from your case, which needs to be connected to the mainboard. That needs to be able to transfer at those speeds.
Yeah, but also the power.
Oh, sorry.
Yeah.
That needs to be able to transfer the power.
But yeah, both speeds and power, because it does support USB 3.2 Gen 2x2, which is also what the header is on this. So that basically has 20 gigabits per second as well. So it has fast USB support and power delivery support on the front Type-C.
Leto on YouTube, if you want how to enter the Assassin's Creed giveaway. Each 6 minutes, we didn't mention that, but you can go to msi.com/2/insider. I think it's on top of the giveaway and behind Mike, and each 6 minutes, I would say, on YouTube and Twitch, you will see the Gleam link on which you can click and participate. Okay, Mike, next one.
No, one moment. Skeet is asking, does the motherboard come with the cable? I think you mean the front USB Type-C cable. That one is part of the case, actually.
Yeah.
So you have the front USB Type-C header in the Prospect, and the cable runs from that header. You can plug it into the front USB Type-C, and then you can use it. So you don't need like an additional cable. If you have the case, you automatically have that cable there.
Now, this is something new. Normally people on TikTok always ask, can I have a VGA card or can I have a mainboard? Victor, of Lasak Victor, he's saying, help me to donate on my PayPal for my PC build. That's something new. So I hope you guys can support him. Yeah, TikTok. That's a TokTik.
Okay.
Okay, next one.
Yes.
You have this one as well, right?
Yes, I do.
Which is the Z790 Carbon Max Wi-Fi.
Yes. And that one also has 105 amp smart power stages, but in this situation it's 19 from top of my head for the CPU. So specifically for the V-Core. Here you see that it's a regular ATX motherboard, so this also fits in a regular ATX case. You have, let me see, this is 4 M.2. Do I say that correctly, Eric?
Which mainboard?
Carbon.
5 M.2.
5 even?
Yeah.
Let me see. 1, 2, 3, 4. Yeah, there are 2 side by side there, of course. Yeah.
2 probably on the bottom one.
So this one is the screwless one on top. And there is a second one, third one, fourth one, fifth one. So this looks like one, but there are 2 underneath. Maybe you can see it like this. So there is, here you can see one, and there is the other. So 5 M.2 slots in total. Let me quickly put this back.
This one comes with the expansion card.
Yeah, so that's a separate add-in card.
I can show you that here.
That's the one we talked about before. That gives you 2 USB 4 ports, and on one of those ports it supports power delivery up to 100 watts. Of course, for that you need to connect the 6-pin power connector on that add-in card. Unfortunately, I don't have it right here, so I cannot
they
show
never
it to you in real
give
life.
us the good stuff, right, Mike?
No, I still hope we can get one, but at this point we don't have it yet. But in case you get this motherboard, it is included in the box, of course. This is still an early engineering sample, that's why we didn't get those kind of things. Also very extensive cooling on the VRM, includes a heat pipe as well. It is a little bit hidden. Let me see if I can show it to you. Ooh, that's hard to see. But there is a little bit of a gap. And you may be able to see the heat pipe, but it's hard, I think. It's really hard to see. It's well hidden, but there is a heat pipe. Oh, here you can see it, here you can see it.
Yeah.
There.
But just very small.
But there is a heat pipe in there connecting the 2 parts of the VRM cooling. Also has some nice RGB lighting, of course, in different places. And then if you would have a look at the I/O, you see that in this situation it's a single LAN port. It is 2.5 gigabit LAN, however. It has 2 times USB Type-C, and this one is 20 gigabit per second. This one is 10 gigabit per second.
Yeah, the labels say so.
Yeah, labels say so indeed. But also make sure that if you have a 20 gigabit per second capable device, that you plug it into the correct USB Type-C port. Otherwise, you may limit it to 10 gigabit per second.
Do you know the number of PCB layers?
Ooh, that's a good question. I think this is a 6 layer, but not 100% sure.
And Godlike is...
I think Godlike is 8 layer, I believe.
Mm-hmm. And the Mini ITX 12?
We don't have a Mini ITX in the Max series.
No, but in B.
But I think either 10 or 12.
Yeah, it was a lot.
So you also get a bunch of USB ports. Again, you have the 3 buttons here, so flash BIOS button, clear CMOS, and the smart button. Wi-Fi 7, of course, antenna points here. It has an ALC 4080 audio device from Riddletech, including an optical output. In this situation, it doesn't include the ESS DAC. That's specifically for the Godlike and the Ace.
So Ninty5 is asking, is there any difference for the 14 Gen PCI Express lanes? No.
No.
Same.
Same, yeah.
Draw29 has some issues with flashing a BIOS. Yeah, it's best to contact our support. They can help you. The contact addresses are on our website, also on Discord indeed, like already somebody mentioned.
Something you can also try, I know some USB drives can be a bit tricky.
The USB sticks.
Yeah, USB flash drives need USB sticks.
Try a different one.
Try a different one. Try one with a light as well. That will make your life easier. And basically the older, the better in terms of compatibility. So if you have a USB 2, like a BIOS file is very small, so a USB 2.0 flash drive is, with a light is perfect for flashing a BIOS. So if you have one of those old drives laying around, try that one.
Yeah, speed doesn't matter.
Yeah, speed doesn't matter indeed.
And the light Mike was referring to, you can see when it's writing or actually reading. So it's
you
actually
can basically see the
that.
progress by the flashing of the light on the USB flash drive.
Yeah. Those boards are already shipping, and in some markets, I don't know the exact details. Probably they're already available in some markets. Otherwise,
it depends on which boards. Some boards are already available. Some, I know, for example,
do you know which one?
Carbon will be slightly later.
Okay.
Tomahawk you should already be able to find.
Might know the details.
Yeah, yeah. So let's talk about Tomahawk, by the way, because that one is already in the market. I cannot show it like this. I can turn the camera a little bit because here is our Tomahawk currently. This is some measuring equipment, so let me move this aside. There we go. That's basically all I can show you, so let's do it like this. This one has 90 amp power stages for the CPU, 16 of them, which is still a lot. So this can still easily power a Core i9. It's only if you want to do like extreme overclocking with the Core i9 and maybe sub-zero cooling and stuff like that you will need more. It has extended heatsink cooling. It has 4 M.2 slots, and on one of those slots it supports PCI Express Gen 5 as well. That's new in this generation because the Z790 Tomahawk, the non-max model, did not support Gen 5 on the PCI or on the M.2 slot yet. It has 2.5 gigabit LAN, USB 20 gigabit per second, so that's USB 3.2 Gen 2 times 2. Wi-Fi 7, of course. Audio Boost 5, in this situation the ALC 4080 audio codec. And it has a little bit of a new look and feel. So it has some accents in, is it green or yellow, Eric? What do you think?
That's the same like the meme on internet with the dress.
Yeah, indeed.
I would say it's yellowish green.
Yeah, so we have the
greenish yellow. That's
the
also
color
possible.
of the MAG series. You can now find in the design. Let me see if you can.
Yeah,
I think the chroma key kind of keys it away, but here these are, for example, in this color.
Yeah.
A bit hidden here, but the MAG logo there as well.
What GPUs do we use today?
4090s.
4090s.
Yes.
There you have it. So a question.
Yeah.
People want to start benchmark. We have one other mainboard, Mike.
Yes. We have multiple actually. But this is our Edge. So this is actually one step up. This is the Edge TI Max Wi-Fi. There we go. And this one also has a 16 amp or 16 power stage 90 amp VRM design. Let me turn this a little bit again. Regular ATX motherboard. It has 4 M.2 slots from top of my head. Yes, let me see. 5. 5 even, yes. This also has
these are the upgraded ones. You know, not like one step, but huge steps.
Yeah, indeed. These have, I think those are the big increases from the earlier generations that supported M.2, they tended to have 1 or maximum of 2 M.2 slots, and that increased a lot over time. So now mid-range boards already have like 4 or 5 M.2 slots, so that's really a lot. And there's a bit of RGB lighting here as well, extended heatsink design, and a heat pipe running through it as well. Yep. So that's not something, for example, you will find on the Tomahawk, but only on the higher end models. So Edge has it, Carbon has it, Ace has it, Godlike of course. Very rich I/O, also with 2.5 gigabit LAN, dual USB Type-C, where again this one is 20 gig, that one is 10 gig. Wi-Fi 7, you don't get the smart button for this one, so that's why you only see the 2 small buttons here. That one is the clear CMOS, and that is the flash BIOS button. Both HDMI and DisplayPort outputs, ALC 4080 audio codec, also includes optical output.
Oh, Mike, I found another one.
What did you find?
Another mainboard.
Another mainboard?
The Pro Max.
The Pro.
Damn. Anyway, let's hurry up.
Yes.
We have 4 minutes left because you want to spend 1 hour on benchmarking.
Yeah, so this is the Pro Z790-A Max Wi-Fi, and this one has 80 amp power stages, 16 of them for the CPU. As you can see, it looks a bit different than the previous generation because there it was mostly black with some silver accents for the Pro series. Now it's basically reversed. So I hope you guys like the design of this. It is a bit different. I think it looks cool. Yeah. But maybe if you like darker motherboards, you may prefer the previous generation better. This one has 4 M.2 slots. So 1, 2, 3, 4. 3 are covered by M.2 Shield Frozzer. 1 doesn't have any additional cooling for the SSD. It does have an integrated I/O shield. In the past, that was not always the case for the Pro model in the Z series, but now we also have it on the Pro boards. Again, you have 2.5 gigabit LAN, of course, Wi-Fi 7. In this situation, you get a single USB Type-C port right there, but that is still 20 gigabit per second, but now you don't have an additional 10 gigabit per second one. You only get 1 button here, that's a flash BIOS button, so there's no clear CMOS on this one. You can, of course, still clear the CMOS by taking out the battery or use the header on the motherboard. Yeah, a bunch of USB ports. Here you, for example, see USB 2.0, whereas on the higher end boards you'll find more faster ports, so either 5 or 10 gigabit per second. But still, for a price, I think very nice motherboard, and still you can, like the VRM is still plenty strong to properly run a not overclocked Core i9 processor.
Next winner. I'm in a hurry, Mike. Don't get me wrong. Next winner. Yeah, he's already awake very early. His name is Udikotidu, whatever. What is his name, Mike? Can you?
No, it's hard for me to read from it.
Udikotidia. Anyway, I think you know who you are.
Congratulations.
Congrats, also with loyalty bonus. If you want to join, you can still win some codes, maybe also in the coming weeks. Go to msi.com/do/insider or on YouTube, Twitch, each 6 minutes we will have a link to Gleam, and most of you already know how to join. Jetleaks on TikTok. Does MSI offer wireless mice? Yes, if you go to a website, you can go to gaming gear, select mice and select wireless. There you can find them. Shall we first talk about memory performance, Mike?
Yeah, sure.
Yeah, because then you can already boot up your PCs. I see actually everything is running. So CPU, not a lot of things changed except for the 4 cores and speed bump. Yeah. Mainboards, mainly Wi-Fi 7 and a lot more of what was already on there. And the BIOS, we have some new features. Let's start on the right side, Mike. The locked base clock.
Yeah, so memory extension mode is basically comparable to the high efficiency mode you may already know from our AM5
let's maybe do that because...
Where did you want to start?
Maybe the locked base clock.
Oh, the locked base clock? You start on the right.
Yeah, I start on the right because the next slide is talking about the left.
Okay, let's start with the locked base. Basically, this is a trick that is available on our MEG motherboards, and that has to do with the fact that the MEG boards have an external clock generator.
Somebody couldn't
So that's in
pronounce.
this situation the Ace Max and the Godlike Max. And with an external clock generator, that basically means you can adjust the base clock. So usually the base clock is 100 megahertz, but for this, with the external clock gen, we can increase it to 102.5. That allows us to run at a slightly lower multiplier to get the same frequency. And that is actually more power efficient, specifically in idle. You will see lower power consumption, but also lower temperatures. But this is specifically something for MEG boards. So if you're getting an MAG, MPG, or Pro board, you don't have this feature because the base clock will be locked. So it is a nice trick that is available on those motherboards. Then, where do you want to continue? Do you want to go to the left, to the bottom?
Maybe the P-cores.
The P-cores. This is something for the i9. i9 on 14th generation can go crazy high in terms of frequency. And it can even achieve over 6 gigahertz. This is something, of course, it depends per exact CPU how far you can go, how far you can overclock with them. You can fiddle around with it. This is also not something you can consistently run on all cores. But for gaming, for example, when you don't utilize all cores, it can run over this. And that's also a bit of a change compared to the 13th gen. There, the frequencies were a little bit lower. Sesco says over 9,000 world record OC. Of course, you can go way higher, but you will have to work with like LN2 cooling and stuff like that with Sub-Zero. Then you can definitely go even way beyond this. But you need to properly cool that. You cannot achieve this under liquid cooler or air cooling. Then where do you want to continue? Memory triad or the
It's
memory
related.
latency?
Memory triad, maybe.
Yeah, so memory triad basically, the name already says it. It tries out how high your memory can go. You can see it over 8,000 megahertz here. This very much depends on your memory configuration. Like if you're using 4 DIMMs, forget it. You're not getting over 8,000 megahertz. So this is mostly something you will see when you want to reach the extremes. You usually go for a single module, also to get lower strain on your memory controller. But it can go extremely high. And this is
I have to say this also depends on your CPU because it's silicon lottery.
Quality of the memory controller.
Yeah. So it's both a combination of CPU, having the right CPU with the right memory controller, and having the right memory.
Mm-hmm.
If you go to our MSI.com website, the product page for these products, you can see which memory they can achieve this kind of clock speeds.
Yeah.
But again, I mean, this is not for you at home, I would say. Just stick to
Cisco also says, so not really that useful for us mortals.
Yeah,
like
indeed.
For regular 24/7 usage, no.
Yeah.
But what does make a difference there is the memory extension mode. And that has an influence on your memory, on your latency. Yeah, we can actually show this, how this works. So let me... let's maybe first, because currently we're running it at stock, so let's first run a stock benchmark in Shadow of the Tomb Raider. Then we can see what our scores.
So we have two systems here.
Yeah.
On the left you see the i7-13700K, and on the right you see the i7-14700K. The configuration is almost identical. I mean, we're using, of course, different mainboards. On the right using the Max carbon mainboard, on the left side we're using the
previous... Max Tomahawk is this.
Oh, sorry, Tomahawk, yeah. And left also Tomahawk, but not the Max series.
It's a carbon on the other one.
Oh my God. I ask you, should we write this down? No, it's easy. So I'm going to switch to the 4700 full screen.
Let me see, let's go to display and graphics. So currently we're running at 1080p, that's also the resolution we're capturing in. Very high settings we're using. And let's run a benchmark. I won't touch these settings after his benchmark because we want to compare with the memory extension mode on or off. So currently it's off. So let's see how it performs.
Yeah. Question on TikTok. Elias LB is asking about CPU compatibility support.
Mm-hmm.
Yeah, all Z790, Z690 mainboards are supporting 14 gen and 13 gen. It's all cross compatible. No problem there.
Mm-hmm.
I hear Dutch. Yeah, that's Mike, his accent. I'm
For
sorry.
14700K, which is the best motherboard, is recommended for daily use, but overclockable with enough VRM. I think VRM power you mean, by the way. Will there be a Z790 Unify X Max for the Intel 14 Gen? No plans for Unify X Max at this point.
No plans that we know of.
You never know. No plans that
Yeah.
I know of, indeed. Could be that we have it in the future, but I simply don't know at this point. For 14700K, with some overclocking, I would say go for like a gaming model, so Tomahawk or higher. I would go for, depending also on how far you want to overclock. But for example, we're currently running that CPU here on the Tomahawk Z790 Tomahawk Max Wi-Fi motherboard. That's a very nice combination, I think. Also depends on what you want to do with your storage configuration. Do you want to use a ton of M.2 SSDs? Then you may want to go for a higher end model. Do you want to have RGB lighting? Then you may want to go for a higher end model. Also the ports you find on the I/O, those kind of things. But from a Tomahawk onwards, for your requirements, should be fine.
Yeah.
Arjun is saying Valorant test. No, we won't be testing any Valorant today. We do have some. Ruud
Mike doesn't know how to play Valorant.
Ruud already did some benchmarking for us before, so we have some graphs that we can show you later on. But for the gaming test live, we will only do Shadow of the Tomb Raider at this point.
We have some more results, but
yeah, we have some more
don't have any
benchmark
Valorant.
results. Unfortunately, we don't
results.
have time to test all those games today. Ian 9K says Valorant can run on anything. What is there to test? That's also true. That's a game you may be able to play in the IGPU as well on these CPUs.
This is a long benchmark, Mike.
Yeah, it is very long benchmark, and we have to run it twice. So this is with memory extension mode disabled, and we will then enable it and see how it
People
performs.
already know the results because it says it reduces 12% latency and gives you like an additional 6% in gaming.
It's situational though.
Yeah,
it
of
depends
course.
per game. Some games rely more on memory, they may benefit more. Some games don't really rely on memory, they may benefit less.
Yeah,
so it
absolutely.
is a situational thing. Also the memory extension mode doesn't give you like any additional frequency. So it's currently running a DDR5 6000 CL40. With the memory extension mode it will still be DDR5 6000 CL40. But some of the other timings will be changed and fine-tuned.
You want me to make some Excel sheet? Or?
No, if you note this down, I'm already happy. This is just, we will get two values. So this is with memory extension mode disabled. And we're getting an average FPS of 303 frames per second. So if you remember that one.
I'm going to write it down, just to be sure.
That's okay. Then I'm going to switch this one off, and we're going to go to the BIOS.
You want me to do this in Excel? That we have some, we can do some difference.
Let's do that for the other one, but for this you don't really need to. I'm quickly unplugging the display port for the monitor, because otherwise you cannot see my BIOS. Then the BIOS will only be on my screen here and not through the capture.
If you listen closely, you hear.
I'm smashing the delete button to get into the BIOS. There we are. So this is our BIOS. For the memory extension mode, you go to the overclocking menu. By the way, make sure you are in advanced mode. You can see that on top here. You can switch to the easy mode and to the advanced mode. So this is the advanced mode. Then we go to OC. And if you go down, here you have all the CPU related stuff, but of course this is a memory thing. So you go under DRAM settings and you see memory extension mode. Currently disabled. Here you have 3 settings. I would say for 24/7 usage, there's basically one setting you want to use, and that's performance mode. So that's also
the one. What memory do you have in?
Sorry?
What memory do you have?
This is Kingston DDR5 6000 CL40 memory. And it's currently running at XMP. So running at 6000, you can also see it right there in the top left.
CL40.
Yeah, CL40. And it will remain CL40 with the performance mode enabled, but some of the other timings, because you have sub-timings as well, they will be fine-tuned. So we're going from disable to performance mode. That's the only different change we'll make in the BIOS. And then we're gonna save and exit. So here you see that that's the only change we made. And then we're gonna reboot. I'm gonna plug my monitor back in. And then we will run the benchmark.
I hope it works.
It should. Vinosi Gaming is asking, does 14 Gen use the same socket as the previous one? Yes, it is still LGA 1700. So the same as 13th and 12th Gen. 11th and 10th are LGA 1200.
Is Memory Triad a memory tester in the BIOS? No.
No.
This is actually, it's a very advanced memory fine-tuning tool.
MemTest is more like a stability kind of test. Memory Triad is more what frequency can my memory modules reach.
Yeah. So you can increase all the values and step by step you can find out what the maximum stable settings are. And yeah, you have so many settings, maybe Mike later you can show.
Yeah.
But you need to be a nerd.
Yeah.
We don't know how to use it. I mean, we know some stuff, but there are so many timings and numbers you can change.
Yeah, the cool thing about the memory extension mode is basically that it's a preset. You only have to enable it to performance mode, so it makes your life very easy. So you don't have to fiddle around with all the subtimings yourself. And still get some extra performance out of it.
No, it's not like Intel XTU.
No, Intel XTU it's a bit like an overclocking kind of utility. Not only overclocking, but later in the stream I will actually use XTU to do some power limiting. This is something I would usually do through the BIOS.
Run the benchmark, otherwise we are here like 10 hours later.
Let me
because
switch
this one
the
takes
benchmark
ages.
on. So the settings still the same. Run benchmark. 303 was the frames per second was the previous result, and now we'll see what we get with the memory extension mode. As I mentioned, XTU I will use later on in the stream also for power limiting. Usually I would do this in the BIOS, but if I do that through the BIOS, I have to reboot the system every time. With XTU, I can switch the power limits on the fly, basically, so I don't have to reboot all the time.
That's meanwhile, I mean, this benchmark is running. Let's go talk a little bit in detail about this memory extension mode. So here you see 4 different benchmarks. We have the same kind of memory. If you use the first line, the first row is XMP. If you select the profile, you don't have the memory extension mode on, you will get a certain amount of scores. You will see that read, write, copy and latency.
So this is actually the memory kit we're also using right now on the system.
So with the high efficiency mode set to performance, so the memory extension mode, you will get faster copy. Well, actually all the scores are going up, but some by a lot. The copy is increasing a lot. And the latency will be lowered and everything will be stable. So if we're going to try to achieve the same, so with this option, you only have to select one small option and you get extra performance. Another way of getting extra performance would be buying faster memory or overclocking the memory clock speed. So we did it by Memory Triad. We use the same memory, we put it at 6400 CL40, so you have a little bit different timings over there. We don't use the memory extension mode, and then you see the performance will also go up, but the latency will not as actually the performance will go up a bit, but not as much as XMP with memory extension mode, and the latency will also be higher. And you can also do that with 6800 with Memory Triad. That's the bottom line.
You can do it, but it's not stable anymore. So.
Yeah. As you can see, the performance is quite good, but it's not stable at all.
Yeah.
So that's why we're saying with this easy, let me switch back. You can pause the live stream if you want or take a screenshot. Which capture, yeah. So we're basically saying, you know, with this option, you can achieve, it's cheaper to use, faster to use than actually having faster memory.
And this is also not something we can guarantee for like every memory kit that this properly works. We do try to fine-tune this for multiple chips, but there's so many variations in different memory modules So this is something that you can try with your memory modules to see if it properly works, but be aware that it may not work for your specific memory kit. So currently we're running the benchmark in Shadow of the Tomb Raider again. Same settings, but now with memory extension mode on performance mode instead of disabled. And we went from 303 frames per second on average to 319 frames per second on average.
Yeah, only by
enabling memory extension mode. So we didn't touch the frequency of the memory. Also the cache latency is still at 40, so still DDR5, 6000 CL40, but with basically what it does is fine-tune the sub-timings, and you see that you get a bit of an increase. And this is situational, so this is a game where you see quite a bit of an increase. It can be that in a different game it barely makes any difference. So it really depends, and in other games it may make an even bigger difference.
Just like 5 to 6%.
Yeah, by just changing one setting. So it's yeah, it's a nice increase, I think.
Yeah. More benchmarking from your side?
Yes, I'm gonna go reboot the system first. To make it even, I'm gonna switch this off again. So we're back to stock with memory extension mode disabled, also to get a fair comparison to the other system. And then let's maybe do some Cinebench 13700K versus 14700K.
When you're in the BIOS, maybe you can show memory try it.
Yeah, sure.
I mean, not use it, but
Yeah.
just show the complexity of it. I think it's like a tool or internal overclocking. Topishi made from himself to make world records. So it's not for everybody.
No. Bashing the delete button again. Was I too late? Oh no. Oh, good. So back in the BIOS under OC settings, and then we go down to the memory section, so DRM setting, and here you see memory try it, and there you have all the different options. So basically there you can choose one, and then it will basically try it out. That's why it's called try it. We're not going to do that for now. We're going to disable extension mode again, because that's the one we enabled. So we go back to disabled to make it fair and square between the two systems. Save and exit, so we're back to the regular BIOS setting. XMP is still enabled, so we're still running DDR5 6000 CL40. Wardog's asking, so do you set up PL1 and PL2 too? Later on I will show you some of the different power limits. I will do that, usually I would do that through the BIOS, now I will do that through Intel XTU, so Extreme Tuning Utility. And that's of course because I don't have to reboot all the time. And there I will show you what setting different power limits does to the performance and also to the power consumption. I do see loading on the capture, not on my monitor yet.
Uh-oh.
Yeah, I was a bit late with the display port. Ah, okay, now I see it again. All good?
I'll go to split screen.
Yeah, sure. Let me start hardware info. Oh. So we got some diagnostic information as well.
SM on the YouTube is 6 minutes. You will see a Gleam link. You can use that for the giveaway.
And Cinebench. So on the left side you see our second benching system, the i7-13700K, so the previous generation. It's just sitting in idle right now. Yeah, you see three
Like
values. You see the clock speed of one of the cores. You see the PSU power out. So that's we are actually using the MEG series power supplies, and they've got a very cool feature it's connected through the USB header of our motherboard, and that gives us additional readouts because it's a digital power supply, and we can actually see the power consumption of the system on the DC side. So that's the direct current side. And we can see the total power consumption. I also have a wall meter here. Let me show you in the close-up camera. This is currently where the 14 gen system is plugged in, and here I can also measure the power consumption of the full system on the AC side, so the alternating current side. Those are not the same, so in both situations you see the power consumption of the system, but on the DC side it's like actually measuring what all the components are consuming, whereas on the AC side, so that's basically on the wall, there you will measure what the PSU takes out of the wall basically, but you always lose a bit of efficiency there because what your power supply does is changing alternating current to direct current, and you always have a bit of efficiency loss there. How much that efficiency loss is depends very much on the load as well. And also
the percentage of the load?
Yeah, the percentage of the load. So for example, if you're on a very high load, on the max of your power supply, it will become way more inefficient than it is, for example, under 50% load. But also how efficient your PSU is in general. So we are currently using 80 plus platinum power supplies. They are very efficient. If you use an 80 plus bronze or even a regular 80 plus, you will see a bigger difference between the AC power consumption and the DC power consumption.
Maybe we should try to do a live stream about this. I mean,
yeah, we can dive deeper into this.
Yeah, that we have the different labels, bronze, gold, platinum, and we check the different loads, what the efficiencies are.
Yeah, that's maybe a cool topic. Yeah. So drop in chat if you would be interested in a live stream about this in the future.
Will take a lot of preparation.
Yeah.
And not for us. Ruud, can you please help us?
But basically, now for example, the 14 gen system, here you can see what it's measuring on the DC side. So it's around 102 watts, it currently says. And on my meter here, it says 106 watts. So it's not a huge difference at this point. So I have a little bit of efficiency loss, but not too much at this point. Let's do some benchmarking, because currently both systems are just running stock settings. Both have XMP enabled, but the rest is all the default settings, default power limits, set to a liquid cooler in the BIOS, which we're also using, 2 liquid coolers. Both have a 360 millimeter liquid cooler. On the 13 gen we have 360R, and on the 14 gen we have the new Core Liquid E360 liquid cooler. Let's run a benchmark. And do you want to start with single-threaded or multi-threaded, Eric?
I would say first single-threaded, because not a huge difference there, right?
You should see a slight difference, because of course the 14 gen got a little bit of a speed bump in terms of frequency compared to the 13 gen, but it shouldn't be an extreme difference. But let's see. So I will start them simultaneously.
Oh, this is difficult. No, that was not. Was it?
I clicked them simultaneously.
Then you moved your mouse. I already see the 4700K is ahead.
Yeah, so maybe I have latency, that's possible.
Yeah, you for sure have latency.
But it looks like
we need to send you to the RMA to fix it.
I think the 14th has overtaken it.
Yeah.
Oh, you also have some latency in the capture, by the way.
Yeah?
Yeah.
So yours already finished?
No, but mine is a bit... Yeah, there is a little bit of latency in the capture as well.
Okay. So...
no, strange enough, it seems like you're ahead for the... No.
I cannot be ahead.
I have to watch it cross, because what's the right for me is the left for you guys, and what's the left for me is the right for you. So it's confusing. Very confusing.
We saw a lot of results in the media already, different benchmarks, and we also saw some differences, especially in power usage. So it seems that different motherboards have different settings, implementations, and this causes these differences. So I think in the coming weeks, months, we will see more regulations or directions from Intel, like these need to be your BIOS settings for certain values. And then I think it will be more clear what the power usage is, because I see a lot of reviews now are saying there is a lot of extra power usage, etc.
Well, you do already have like a defined Intel spec, but we can, for example, choose to unlock more things to get more performance out of them. But in certain situations, that can come with a higher power consumption. Basically, there are multiple settings. So in our BIOS, there is also a preset that if you select the air cooler one, you will stick to the Intel settings, for example. Now we selected the liquid cooler preset, and that will unlock some more possibilities in terms of power draw. But then it will also consume a little bit more power. Let me open up HW info, by the way, on both systems. There we go. So you can also see some statistics. It's currently running on a single core, so that's why you see the temperatures are still very low, or both at like 40, 50 degrees, that depends a bit. It's core max, so basically it picks the hottest core in the CPU, and that's the one that it shows. Power consumption is currently for the 14 gen system at 124 watts, and 128, 130 on the 13 gen. Of course, we're not running 100% identical systems, so there can be a slight difference there as well, but they're very close in terms of power consumption. And this is, of course, a single-threaded test, so it kind of makes sense that they're very close. And then you see the frequency on the top, and 14 gen is currently running at 5486 megahertz, and the 13 gen at 5287 megahertz. So basically 200 megahertz difference, like specification.
Yeah. Like advertised.
Yes. Can you guys show the V-core voltage? Eric, actually you can if you show the full screen, because I have it on the site in HW info. So this is the 14 gen system, and here you see the V-core voltage on the right in HW info. And maybe we can also switch to the 13 gen, and you can also see that voltage. And this is stock setting, by the way. Later on I will fiddle a bit with...
Fiddle a bit like plus 2 volt, or what does it mean, fiddle a bit?
It means like I will give it basically an undervolt is what I do.
Oh, okay.
I will use the CPU light load mode. And basically I will try to get the same performance out of the CPU with lower power consumption. So try to optimize it a bit. And this is very much a trial and error thing, and also very much depends on the exact CPU that you have, whether or not you won the Silicon Lottery.
So this is why we're probably here for another 5 hours.
Yes.
Mike and Ryan.
At least. Maybe you should call home that you're late today. Arjun says, I want to win the giveaway. What should I do for it? Enter the giveaway in Gleam, and then you have a chance to win. Yeah,
so YouTube, I see you're on YouTube each 6 minutes with the Gleam link. So gleam.io, or what is it? Yeah, gleam.io.
Yeah, gleam.io indeed.
I can also put it in the chat. Ooh, but then if it find the right link.
Yeah, you have to go to the main thing, go back.
Go to the main thing.
Just press the back arrow.
Yeah, true.
And then on the bottom you see the link. No, one higher there.
I think this is the one.
Yeah, that's the one.
Yeah, okay. One moment.
So Eric will also drop it in chat now.
Yeah. I'm not sure if it will post everywhere, but...
Wardog says, well, I will say that X3D CPUs use much less power than 13th and 14th gen.
So Marco, we just posted the link.
Yeah, X3Ds are interesting CPUs because they get a lot of performance out of the 3D cache that they're using. That also means that they're clocked relatively low, and that reduces the power consumption. So X3D CPUs are actually more efficient than regular X series because they're clocked slightly lower, and depending on the game, but in most games they do get a bit more gaming performance there. On the other hand, for productivity workloads, it's usually not that beneficial. Of course, also depends on the exact type of productivity workloads, but if you use like Cinebench, which is like a rendering workload, you
one
see
is finished, Mike?
Yeah, one is finished. So close to 2200 points, single-threaded.
Oh, nobody can see that.
It's, yeah, can you go to the full screen?
Yeah, I was waiting until the 13700K was finished.
So this is the 14 gen, so that's 2176 points.
You want me to write that down?
Yeah, you can. But
No.
later on we will compare.
I want to hear a yes, not like, oh, yeah, I'm not really going to use it, but...
For the later tests, I will use the multi-threaded one.
Okay,
because it's a
I'm
way
not going to
quicker
write
test
this
as well,
down.
so I can quickly show you what it
Yeah.
does. And that's also where the power limits will make a difference, because this is a single-threaded test. It will only load up a single core, so you will never run into the power limits with a single-threaded test. So that's also why, for the comparison, I will use the multi-threaded test in Cinebench.
Okay, so this is 4700K. Now I'm switching. So this was 2176.
Yeah.
And now we have, whoa, the 13700K.
2066 points for the 13700K.
Yeah, so it's about 100 points difference.
Yeah, it's about 100 points
110.
higher. Yeah, and that of course has to do with the higher frequency. Quickly getting back to the X3D story, lower frequency does mean that in productivity workloads, like for example Cinebench, it will also score lower. So in the rendering workloads, for example, also the AMD X CPUs tend to be faster than the X3D ones. So it really depends on what you want there. That's also why for the Ryzen 9 X3D ones, you see that only the single CCD has 3D V-cache and the other one has not.
I'm going to do another giveaway, Mike.
Yeah. I'm going to start the multi-threaded benchmark. That will be a much shorter one than a single-threaded, because basically it's rendering the same image, but now it will use all the cores in the CPU instead of just one. So I'm going to try to do them at the same time again.
Oh, let me go back, split.
Let me go back to the HW info. So now it's running all cores, so you see the power draw is completely different now. So the 14 gen system is pulling 372, 76 watts, and the 13 gen is at 380. So again, it's very close in terms of power consumption at the moment. Oh, it's already done.
Yeah.
So the score for the 14 gen is 35,330 points. And for the 13 gen, it's 29,337 points. So here you see the difference is a bit bigger. And that of course has to do with the fact that the 14 gen Core i7 has 4 additional E cores. So it simply has more cores than the 13 generation. So in a single threaded workload, you see a tiny increase because of the speed bump that it had. In a multi-threaded workload, you see a bigger increase because of the additional cores. So for productivity workloads like CPU rendering, like we're doing in Cinebench right now, you see that extra cores will give you better performance.
They should have called it the refresh and not a new gen. Well, actually they did, but not in the marketing name.
Yeah, in the code name it's also Raptor Lake refresh.
Yeah.
So you have 12 gen is Elder Lake, 13 gen is Raptor Lake, 14 gen is Raptor Lake refresh.
Yeah.
Yeah, Intel is a bit, they've done different things in the past. So if you had the 4th generation, you had like the 4770, and then you had the 4790. So that was Devil's Canyon, I believe was the code name. So for that one, they didn't make it a new generation for the speed uplift basically. But also for the 6th and the 7th gen, there they did, because basically the 7th gen is technically same as the 6th gen, but they got a speed bump, and I believe they added Optane support or something like that. So they've done different things in the past, but basically in terms of architecture, in terms of the, it's still the
Mike, is 380 full system draw or just CPU?
This is the full system. This is a full system.
Yeah, I'm asking because the stat is disappearing.
No, we're doing this on purpose because the package power value is a bit off. So it doesn't give us proper values to work with. That's also why we opted for a digital power supply, so we can get a good measurement of the full system. So this is specifically, or this is the whole system and not specifically the CPU. Yeah. But they're very similar systems. They both have 2 DDR5 6000 memory modules with RGB. They both run an RTX 4090.
It's also because we're using different mainboard, and they measure the power usage a bit different.
Yeah.
So it's not comparable.
There is like, you will see a slight difference here, but it will give you a good indication of what kind of power consumption you can expect of a system like this. It's not like it will be 100 watts off or anything, not even close. Later on I will also fiddle a bit with the settings of the 14th gen system, so you can see what kind of scores you get out of it when you power limit it, for example, or when you're going to play with CPU light load, where you're basically undervolting the CPU.
Next winner, Wessel 1808. Congrats.
Congratulations.
If you want to participate, you can still join MSI.com/insider. We're giving away Assassin's Creed Mirage, or on YouTube and Twitch. Each 6 minutes, the bot will post the Gleam link. That sounds nice.
Yeah.
Posts, not spams.
I'm quickly going to run the multi-threaded benchmark again, because there's something...
Should I write this down?
Yeah, you can write down the scores.
You can. Shoot.
Yeah, these please do. Because this is the one I will compare later.
Okay, 1 moment.
Yes.
Write them down.
So it's 35,330 for the 14th gen.
1 moment. I'm not that fast.
Come on, takes long, Eric.
I'm setting up my...
I thought you wanted to be home in time today.
oh, okay. We're going to blame me.
Of course.
Okay, so 35.
Mm-hmm.
And then?
330.
330, yeah.
And 13 gen is 29.
29.
337.
337.
Yeah.
Okay, and what are you going to change right now?
First I'm going to run it again, because I want to show you guys something for the temperature behavior that was quite interesting. Because we saw that basically the power consumption was very close between these two. But for some reason, and I cannot properly explain it at this point, but I do want to show it to you guys, is that if we measure it through HW info, you see that the CPU temperature of the 13 gen is significantly higher.
13, sorry.
Yeah, the 13 gen is currently 92 degrees, running the same benchmark, and 77 degrees Celsius for the 14 gen. I don't know at this point why this difference is so big. So either Intel did some optimizations for the temperature that makes the temperature lower, or they changed something in maybe the position of the sensor or the sensor itself. So I'm not 100% sure why this difference is so big, but I still wanted to show to you because it is quite a significant. It like peaked at 80 degrees on the 14th gen, and it peaked at like 93 degrees on the 13th gen. So that is quite a big difference, because as you can see here, the power draw is not too far off, like approximately 380 and like 376.
Could be a sensor problem.
Could be, or maybe not a problem, but a change, or they fine-tuned it a bit. I'm not entirely sure. But it could also mean that the 13 gen will thermal throttle a bit faster than the 14 gen, because it runs into temperature limits sooner. But at this point, I don't have a clear explanation for this.
Yeah, so Intel didn't release a lot of data, like what they changed. Probably, I mean, most likely the production process matured, but this is a big difference.
It is a big difference, yeah.
Yeah. So we think it's something different.
It could be, or they found something really clever that made the temperatures quite a bit lower. I'm not sure what the cause of this is, but I thought I will show it to you guys.
Maybe
anyway, so
it's a small bug in the BIOS of one of the boards.
Could also be.
We don't know.
This is at basically unlimited power limits. So let's boot up the extreme tuning utility.
You want me to write these ones down as well?
No, it should
almost identical.
It should be almost identical, because I didn't change any settings. We're basically going to toss the 13 gen system aside, and we're going to do some fine tuning on the 14 gen. So let me grab my mouse a bit closer so I use the correct one. For this, I will use the extreme tuning utility from Intel to set some power limits. So you can also do this in the BIOS. That's what I would usually do, because you do it on a hardware level then instead of a software level. But I don't want to reboot all the time. So that's why for this demonstration I will use XTU.
XTU is a free tool from Intel you can download in case you're running an Intel CPU and a mainboard that support it, or a chipset that support it.
Yeah, indeed. So on the left, if you go to advanced tuning and you scroll down a little bit, you see these two values. So Turbo Boost Short Power Max. And if you look in the information thing, you see that this is the PL2 limit. So this also in the BIOS, you will see PL2 for this.
Yeah.
And
that's also a bit of a information gap between what's written in the BIOS and how it's called here.
Yeah, but
Here you
here
have the
with the
fancy
info you
marking
can
names.
see what the value is that you're changing here. And this is the Turbo Boost Power Max. So short duration, as it already, or short power, is like for the short duration. And here you can see how long that is. So that's for 56 seconds edition. This is also something you can adjust. And basically that means that within the first 56 seconds of load where it wants to boost, it will give you, in case you set that up, of course, it can give you higher power limits. So, and this very much depends on your cooler. Like if you're using a more limited cooler, you cannot use very high power limits for a sustained period of time. But by having them for a short period of time, you can still speed up your system a bit in certain workloads that are not very long. So for example, you could set this to 200 watts and maybe that one to 100 watts. But this depends very much on your cooler. Today we're using a very powerful cooler, the Core Liquid E360. So basically we can set them at the same value. That's also what we will do. So for this demonstration, we will not make a difference in PL1, the long duration, or PL2, the short duration. So I will make these two values identical. But this depends very much on your cooling, what you want to do. If your cooling is more limited, you may want to lower down the long duration, the PL1 power limit a bit further.
Mike.
Yeah.
Shouldn't I have written down the power consumption?
You didn't?
No, you didn't. No.
Okay, let's run it again before we change anything. That's okay. But that's a good point, actually.
Yeah, I know.
Because that's what we want to compare.
Yeah. Only going to do 14 gen with the power consumption?
Let's. I still keep it to unlimited right now, and I'm going to run the 14 gen again.
Yeah.
So let me put this to repeat, so it just continues until I stop it, basically, instead of a single benchmark. So this is with XTU set to unlimited. Higlot says, so how does this compare to the 13700K? Basically, what I will demonstrate now in terms of power limits and stuff, you can also apply to a 13700K if you want to. You can also use Intel XTU for that. You can also do that through your BIOS. The scores we just compared between them in stock, and now I will show you how to fine-tune the 14 gen model a bit. But everything I tell you for the 14 gen, you can also do on a 13 gen. Mr. Masterdog says, oh, it's about 14th gen Intel. Is it not a Ruud episode? Usually he would, but Ruud was unavailable today, unfortunately. He did do some testing, so we
and
will
they asked me.
No, I asked the cleaning lady first, but she wasn't available.
Yeah.
And yeah, in the end I had to go with Eric, unfortunately. But we have some of Ruud's test data to show you later on as well.
Yeah. And I'm giving away Assassin's Creed Mirage, so I'm compensating for my...
Indeed, indeed. He tries to make up.
Yeah.
Okay, Eric. So currently we're looping the Cinebench R23 multi-threaded benchmark.
Mm-hmm.
And as you can see, the power consumption is like around 380 watts.
Okay.
So it hovers around a
Core
bit.
Max,
but
you don't want me to
like on
temp?
average around 380 for the full system.
Yeah, temp?
Temperature, yeah, a little bit over 80, 81, 82. It's like, yeah, usually between 80 and 82. So let's say 81.
Okay.
And now I'm gonna stop this one. And I will go back to XTU. I'm gonna put this back to off because first, when I put on a power limit, I also want to see the score. So I'm gonna run a single benchmark for that one. And then I will loop it a bit so we can also compare the power consumption and the temperature, because if you run multiple tests, the temperature rises a little bit. Back to XTU. By default, this one maxes out at 253 watts. So let's maybe go to 200 watts to see what it does. in this situation, we use a proper cooler, so I will set also the long duration one to 200 watts. Apply. And then we will slowly go down. So we do 175, for example, 150. Or do we maybe want to do 225 first? Let's start with 225. And then we will lower with 25 watts each time. Okay. So 225 power limit. And then we first run it for the score. So we run a single benchmark of multi-threaded. Warlock says adjusting the boost time. Now I don't adjust the time, but also I set the PL1 and the PL2, so the long duration and the short duration power limit identical. So it doesn't matter if I change the time now because the power limits are the same for each of them. But this is something that depends on your cooler if you can do this.
He wants to see
not.
fire.
Yeah. Okay, so I power limited to 225 watts, so you can already see the power consumption is a bit lower, but the score, Eric,
yeah.
34,695.
695.
And I'm gonna loop it a bit to see what we get.
30 minutes?
No, I don't run it for 30 minutes. But to see what the temperature does when you run multiple loops and also what the power consumption is. So here you can see that the power consumption was around 380 we said, right?
Yeah.
And here you see it's already a little bit lower. So we're at like 348. I think that was my mouse wiggle maybe. We had a small spike here. Let's say 350, Eric.
Come on.
So we went from 380 to approximately
Don't use your mouse.
350. And the temperature, we were at 81.
Yeah, 81.
And
74 on average?
Yeah.
I mean, I see 75, I see
75 approximately.
What?
74, 75.
Yeah, 74 I'm going to use because that's the average.
So we already lowered like 6 to 7 degrees Celsius, and we lost 30 watts.
Yeah.
Okay.
Yeah. My Celsius is a copyright mark, but
it's interesting.
I can share the results with you. Where are we?
So we're currently running at 74 copyright.
Yeah. I can.
Okay, so I'm gonna close this one because we're not getting much higher in terms of temperature, power consumption, so quite steady. So let's stop the benchmark. Then we go back to Intel XTU and change the power limit to from 225 to I pressed it twice, to 200 watts.
Oh,
there we go.
Here you are.
Yeah. So 225 to 200 watts. Apply. Okay. Let's first do a single run again to see what kind of score we get now. Oh, it's still quite quick. So this at a 200 watt power limit for the CPU. Okay, now the score is 33,827.
Yeah.
And then I will loop it a bit again to see what the temperature and the power consumption do. So power consumption, yeah, 318, 320. Let's do 320 watts. It hovers around a bit, but 320 on average I think is quite fair. And then the temperature lowered to approximately 68 degrees.
68.
Yeah. 68 copyright.
Well, I'm changing that. Yeah.
So 320 watts and 68 degrees Celsius. Okay. Then I'm gonna stop that one again, and let's go back to extreme tuning utility, and then we go from 200 watts to 175. There we go. And apply. And let's first do a single run again. I can already hear that the system is becoming a bit more silent now. So the fans of the liquid cooler can run a bit lower. Okay, so the score, Eric,
Yeah.
is 32,573.
573.
Just for comparison, because I still have the 13 gen system open. So the 13700K on stock did 29,344. So we already power limited this quite a bit, and it's still scoring more because it has more cores, of course. Then we're gonna loop this a bit because you still need the temperature and power, right?
Yep. You have an easy job, just changing some numbers.
Yes, and you have to do all the statistics.
Damn.
So the power consumption is around 290 watts for the full system. And here you can see that you lose a bit of efficiency because at the wall I currently measure 312 watts. So there you get a bit of a difference now. NRT says, what temperature will the cooling fans stop at? At the CPU cooler they don't. These are not semi-passive, so they will always run. They will just spin at a lower RPM. But the fans of the graphics card are of course switched off at this point because it's CPU level. Okay, Eric, so 390 watts you have written down, right?
I wrote down 290.
290, sorry, 290. Yeah. Temperature, 62 degrees, 63, 62. It's hovering a bit, now it's in between runs. Yeah, let's go 63, copyright.
63.
63.
Yeah.
Okay, I'm gonna stop this one again. Back to XTU.
Go lower.
Yeah, we keep on going lower and see basically when we're in the performance zone of the 13700K. So 175, then we go to 150. There we go. And Cinebench, first a single run for the score.
Damn, I'm really going to be here long.
Michael says, are you guys running XMP also? Yes, we are. So the memory is currently running a DDR5 6000 CL40. So Eric, we're at 31,422.
Yeah.
Okay. And then we will loop it a bit to see what the power consumption and temperature do. So we're around 260 watts currently.
One moment. What was it? 260, right?
Yeah.
Yeah.
And we are running, let's say, 56 degrees Celsius. Okay. Next one. 125 watts. So now we're power limiting over half of what it would do by default. And by the way, with the previous one, we were still ahead of the 13700K because we were at 3144 points and the 13700K was at 29344.
Yeah. That's why I'm worried.
Now, single run for the score. Mikey was asking, what's your guy's ambient temperature on? Eric, can you look on the air conditioning screen?
12. No, 22.
Okay, 22.
Oh.
22 degrees Celsius. Okay, Eric. 125 watt power limit, and we're at 29,891. So
Yep.
29,891. And then I will loop this again. Fijo is asking, what's the minimum watt value it can reach? Do you mean like the minimum value I can set in XTU as power limit? I don't know actually. I haven't checked.
We will get there.
I never went that far because at a certain point, of course, you do lose
You
a
want to
lot
go
of
home
performance.
at a certain point?
That too. Okay, Eric, we are at 230 watts.
Oh, did it already wrote? Oh yeah. Sorry, yeah, 230. I see a pattern. Each time it's losing 30 watt.
Yeah, makes sense.
Can I guesstimate this one? I would say 50. Hey, look at that.
Well, that was in between runs. It's a little bit higher.
Okay.
Let's say 52 usually.
Okay.
Yeah. Okay. And I'm going to close this one. And actually, the score at a 125 watt power limit on the 14700K is still higher than the 13700K on the default setting.
Yeah.
So this is getting much more efficient now because power consumption on a power limited 14700K was much, much lower than on the 13700K stock. Of course, you can also do this kind of fine tuning and get better efficiency out of the 13700K because we are comparing this to stock currently. Then let's go to 100 watts.
Yeah. The last one. Oh no, we can go lower.
We can go lower. And let's
Single
first
bench.
do a single run for the score.
Yeah. I would say. Oh, I need to be quick. Oh, that's difficult. I would say 28. 28, 9, of maybe 30k.
30K, we were already in the 29, right?
Oh, sorry, 29k. I would say. Oh, you know, close to 29k.
Close to 29K.
Yeah, maybe a bit lower.
Yeah, this is a bit lower.
Whoa, that's a big step.
Yeah, so at a certain point, you reach like a point where you get out of the efficiency sweet spot, basically. Yeah. And then you will see that by power limiting it further, you will get more significant, like lowering the score. So the performance will suffer significantly at a certain point. So I think in terms of efficiency, 125 may be a good one to aim at. So 27445, Eric.
Yeah, wrote it down already.
And then I'm gonna see what it currently does in terms of power consumption and temperatures. So we're now at 200 watts power consumption, Eric. So as you can see, each time I lower it by 25 watts, but you see a reduction of 30 watts of the whole system.
48, 47 maybe? Oh, maybe even lower.
At this point, yeah, but we'll let it loop a couple of times because it may go a little bit upwards. And that has to do also with the efficiency, of course. If the load is lower, the VRM will work more efficient. So that's why even putting it 25 watts lower, you will have a bigger reduction in what you actually consume in terms of power. So each time we've basically seen for every 25 watt step, we saw a 30 watt power reduction of the total system. Let me see. So Eric, we're like running 46 degrees Celsius.
Okay.
'46, 47, yeah. It hovers a bit in between. Yeah, next one. And I think now we will see the performance reduce quite quickly because we already saw last time we got a bigger dip than what we saw in the beginning. In the beginning we saw very small steps when reducing the power limits, but now we saw a bigger one.
My calculation is broken.
So when we go even further to 75 watts.
V1.
First do a single benchmark test for the score. So at this point we're already slower than a stock 13700K, of course, but at a much, much lower power consumption. Okay, Eric, 24062. So now we see bigger steps. Because we were in the 27s, right? So with these 25 watts lower, we lost over 3,000 points, whereas in the beginning, we lost like 1,000 each time or something. Tom 3D2 says 75 watts is probably equivalent for i3 for power level. Yeah, approximately. Depends a bit on which one and what kind of settings you run it at, of course. But
my Excel is broken.
Your Excel is broken?
Yeah.
Let's loop this one. Did you still get to 24062?
Yeah.
Okay.
What the hell? Oh, I'm not allowed to say that on stream, right? Okay.
No, you can't.
Yeah, I just did. This is really strange.
Simone Fiorini says my 7950X bench 36K on Godlike. Yeah, that's actually very similar to what this CPU does without power limits.
Mike, information, I would say 170.
Let's see. Yeah, that's a very good guesstimate.
Yeah.
It's indeed 170.
And 40?
Yeah, also good. It's hovering like 40, 41.
Yeah, I see a
let's say
pattern.
40, yeah. Okay. Now, how low can we go? Let's go to 50 watts.
Oh. Nah, I'm joking.
Such a lame joke, Eric.
Well, we have it for a reason.
That's true.
So it is 50 PL.
Yeah. 50 watts.
So this will be 21K, I would say.
Could be even further, because at this point,
yeah,
you're really bottlenecking the CPU by the power you
put in it.
Yeah, or don't put in it, basically. 186.
Oh, 186, yeah.
So at this point here, so you can also see it a bit in the overview, in the previous test we were still faster than an i5-13600K. At this point we're not anymore by power limiting it this far. We're gonna loop this again and see what it does in terms of power consumption and
140.
temperatures.
And 35, 34.
Let's see.
Oh, 142.
Yeah, 138. Yeah, 140 is accurate.
Yeah. And I set for power, what did I say? 34 something, right?
Yeah, 35 I would say.
Okay.
35 is the most common one.
Yeah. Should I write down 25 watt PL?
Were we at?
That's more like a Core 2 Duo.
Okay, so this was the 50 watt power limit, and we had 140 and 35. And then let's go even lower. Let's go to 25 watts. And then
It's like an ultra thin notebook CPU.
yeah, this is getting really into that area for sure. You can also notice now in the benchmark that it's significantly slower. So we started, what was our first score with the stock one? Was like 35, 36K or something?
Yeah, 35, 330.
Yeah.
So now we're getting in half of that performance, like 15, 16, 17K somewhere.
Could be even lower.
Yeah, probably lower.
Because at this point you're losing efficiency.
5K,
we're pushing it like below the sweet spot now.
Yeah. CPU doesn't know that there was a sweet spot.
Because you always have like a fixed consumption, basically what the CPU already uses by default.
The memory controller.
Yeah. So the current power limit we put at, it cannot use all of it for the cores.
Yeah. But still faster than getting a cup of coffee, right?
So we're at 11.
Oh my god.
617.
617, okay.
Yeah, let's close it here because 0 watts is
Oh, we need to do a run.
Oh, that's a good one. The temperature power consumption run. Okay, let me loop it.
Because my Excel file said so.
Yeah, Tom was indeed close. He guessed 12100.
What's the next one you're going to do?
How do you mean?
Yeah, I mean 0 was not possible.
No, so I'm not going any further because I take 25 watt steps all the time.
Yeah, and if we go like to 5 watts, probably we're here 6 hours benchmarking this stuff.
It will probably need that for the memory controller and stuff like that already.
Yeah.
So
okay,
25 watts is the
so this should be 110.
Okay, let's see the statistics. Yeah, 110 is approximately accurate. It's hovering from like 110, 112.
And then it should be 29-ish.
Yeah, 30.
Okay, we're right down 30. You also see that the temperature is not, it's losing less and less a degree.
Yeah, at a certain point, that's a curve indeed.
Yeah.
But now you already see that the idle temperature is barely any higher than what is currently running under load. For as far as you can still call it load with this power limit. You can also see now the frequency, even though we're putting load on the CPU, the frequency is it's underneath 1700 megahertz. So that's a lot lower than the 5 point something that you would usually get on a P-core. Okay, let's close this one. Shall we have a look at your overview, Eric?
Yeah, I need to zoom out a bit. Yeah, this is it.
And, I'm gonna go back to unlimited here.
I hope this is readable for everybody. But we have here 14700K, Cinebench core, the total system power, and the core max temperature in degrees Celsius, or the degree copyright. Unlimited power limit, 225, going down with steps of 25 to 25. So, and this was the benchmark score. Can we maybe have the temperature of this 3700K?
The temperature?
Well, I mean, just run the benchmark.
You mean just on the stock setting, right?
Yeah.
Yeah, let's do it. I will loop it in a test. And let's go here.
I assume that's also unlimited PL, right?
This is unlimited, yes.
Yeah. Oh. Okay, so the temperature we better don't write down because that's probably a bug.
No, I don't think the temperature is a bug.
You don't think?
No.
Put your hand on it. Prove it. If it sticks, it's true.
Oh, this is also still very much within Intel spec. That's okay.
Yeah, first was 81, yeah.
You will see it go a little bit higher now. That's because I'm looping the benchmark. So it doesn't have the time to cool down in between, basically, because it starts over and over and over. So it already starts at a higher temperature when it starts the next test. So you will see it increase a bit compared to a single run. So what we saw is that the score of 125 watts power limit on the 14 gen is very comparable, right?
Yeah.
Even the 14 gen was even still a little bit faster there, I think. So what I'm gonna do is I'm gonna power limit it again at
388, right?
Sorry, 388.
The wattage 388.
Yeah, 390, 388.
388.
386, yeah, 388 approximately.
And what about the temp?
Temp is like 95, 96.
95.
Now it's in between loops, so it's 95 approximately.
Are you going to do the same for this one?
I'm gonna do a 125 watt power limit because we saw that was very comparable in terms of performance in a rendering workload.
Yeah.
And I'm also gonna loop this one. And then you can see the difference in efficiency, basically. Where did I have my HW info? So maybe we can do the side-by-side again. Because now they're basically rendering at equal speeds. So they take approximately the same time to render this image. And you can see that the power consumption on one system is around 230 watts, whereas on the other one it's close to 390 watts. Also, the temperature is now 96 degrees, 97 degrees on the 13700K and 50 degrees on the 14700K. So this is equal performance, but one is an optimized 14th gen, and the other one is a stock 13th gen.
And you also wanted to do 125 PL with that one or not? With the 3900?
I don't know if that one is XTU installed, but we can. We can check.
I don't know. I mean, you were talking about it.
I was actually, because we're running a bit short of time, maybe let's have a look at the CPU light load. I think that's an interesting one as well.
Well, let me maybe show the Excel sheet again. So here is basically what Mike is showing right now. So at 125 watt PL, it's doing even a bit faster, not much, than the 3700K, but power usage is a huge difference. 230 watt versus 388 watt, and temperature 52 degrees Celsius versus 95 degrees Celsius.
And keep in mind that this is at the same price. A 13700K and a 14700K have the same price. If you do a bit of fine tuning, this is a really interesting processor. Like, as you also saw out of the box, it does consume a lot more power than it does right now. It was very close to the 13700K actually. But you can make it perform similar to a stock 13700K at much lower power consumption because you have those additional efficient cores in there.
You're now going to...
Let's do some CPU light load in the BIOS.
That's the 4700. I'm going to do a giveaway.
Yeah.
Already overdue.
I'm going to set this to unlimited again.
Let me see. Yeah, so it seems you still can participate. Because Mike continues to... Mike is like Peter today. He continues to talk.
I'm going to reboot to the BIOS quickly.
Yeah. And I'm going to do a lucky draw.
And let me plug out my monitor so you can actually see what I do in the BIOS.
Next winner, Glacial Hell. Congrats.
Congratulations, Glacial Hell.
Yeah, you can still participate. Go to msi.com/2/insider or on YouTube and Twitch. You can find the Gleam link. And yeah, we'll do at least one more giveaway. And of course you can win an Assassin's Creed Mirage. I can share my save file as well. Oh no, it's in cloud. Then you can skip 13 hours.
Okay, go back to the chat.
Oh yeah, sorry.
Okay, we're back in the BIOS. Right now in the BIOS we're still running stock settings basically. But if you go to the overclocking settings and you go to advanced CPU configuration, so like what I showed you before with the power limits is actually a very safe way of saving power while still being sure that you will have your stability. So you don't lose any stability by power limiting it, you will just make it a bit slower at a certain point. Of course, in the beginning you don't lose much, but as soon as you go down and down, then performance also goes down. The next thing I will show you is actually very comparable to what you may be familiar with from AMD's Curve Optimizer. Then we're essentially undervolting the CPU. So this also means that if you go too far with this, your system can become unstable. That's not the case with power. It will become unstable. But it also very much depends on this exact CPU you have, so the silicon lottery, how good your specific CPU is. Also the motherboard that you're using, how steady the power delivery of that motherboard is to the CPU. So there are many variables that can influence this, and this is also more of a trial and error thing. This is a more advanced thing, because if you don't do this correctly, your system is unstable, whereas with power limiting, you don't have to worry about that.
Yeah, so I think this was Impulse60 in YouTube already said this before. There are different ways of underclocking.
Yeah.
And so we use the power limit. Now we're going to use a different function.
Yeah. And
it's quite simple.
This is the CPU light load, and basically what this does, you see different modes here. Currently it's at auto, and that's comparable to mode night. These all give you a higher voltage. So if you go to a higher one, it's a higher voltage, so it will consume more power, produce more heat. If you go here you're basically undervolting it. So
Mike, we should tell our BIOS team that this should be more clear.
Yeah, I think the curve optimizer is currently clearer because you can just set an offset in terms of
go higher,
voltage.
you get more voltage.
Yeah.
I mean, I cannot see it in the description.
You can see it in the description.
No.
So on the right you see sets the CPU light load mode. Higher leads to higher CPU voltage that could stabilize the system. So lower means lowering the voltage, which could also destabilize the system. So the default is 9. We are a bit limited on time, so I know this CPU...
Otherwise Mike would have tried all settings.
Otherwise I would have done a step in between, but I know this specific CPU, and that's the case for this one. So if you have the same motherboard and also 4700K, this may be different for your exact CPU.
Silicon lottery.
Yeah, maybe you can even go to 2, maybe you can only go to 6. So that's something you have to try. I'm going to do 3, and that's all I'm going to change. And then we're going to run some more Cinebench and see how it performs and what the power consumption is, and we will compare that to the stock setting. So the goal... Star Citizen 88, we're using the Z790 Tomahawk Max. Yeah, Tomahawk Max Wi-Fi indeed. The goal of this is not really by undervolting it, is that we don't really use any performance, but still get better power efficiency out of it. So unlike power limiting, where at a certain point, of course, you lost a lot of performance, by undervolting it, we try to establish the best of both worlds. So both lower power consumption, but still the high performance. So that's what we're aiming for. So let's go back to Cinebench. And we will run a single run for the score.
I'm ready. I guess is quite fast. Mike, 35?
Yeah, 35 half.
35 half?
It should be very comparable to what we had originally. It could maybe be even a little bit faster because you see 36 to 44.
Okay.
And that's kind of also what you can, for example, achieve with Curve Optimizer. I also did this. I have an AMD PC. I also did that on my PC. By lowering the voltage, it can sustain the higher boost frequencies for longer.
What was it called? Light load.
CPU light load.
Light.
Light is an LITE load.
Oh, that kind of light.
Yeah.
I thought like light.
No, not that light. Have you seen the light, Eric?
Okay, do a run, please, for system power and core max. Temps.
Oh, I did cheat a little bit, I see, because I didn't have HW info booted up. That can have a slight negative influence on the score because you're running something in the background.
Do it again, it's fast enough.
So let's maybe run it again. It's quick anyway.
But I like the 36K.
Yeah, so basically there you see that it performs similar to, someone in chat said, here's 7950X. That also performs around 36K in Cinebench. Could even be slightly higher, I think. NRT says, what kind of CPU do you have in your AMD PC? I have a 5600X, just a Ryzen 5.
Yeah,
but I have a very small PC, so I cannot cool too much with my 92mm.
Okay, Mike, you can run it in...
Yeah, so still at 36K.
Yeah.
So as you can see, it even performs slightly better than the stock setting. So with unlimited power settings. So now we're going to loop this, and as you can see, it didn't crash. It's still a perfectly fine stable. This also a stability test.
Didn't crash yet.
Didn't crash yet. So right now, it actually performs slightly better than the stock setting, but we're at 320 watts power consumption.
Whoa, nice.
And Eric, what is the stock one?
380.
380.
So this is comparable, what was it? 320. Comparable to 200 watt PL, power limit.
Yeah, but now we don't have a power limit, but we still get the same kind of power consumption. Yeah. But we get more performance, because what was the score for the 200 watt power limited one?
200 was, let's say 34K almost.
Okay, 34K, and now we're at 36K.
Yeah. Later you can see everything in my Excel sheet. I need to have some added value here today, right?
Yes, indeed, Star Citizen. I love small computer cases, definitely.
Yeah, and I hate them.
Yeah,
And I speak from experience.
Yeah. We should do an even tinier build for you next time.
Yeah. Keep dreaming. My hands are too big. So what's the core max? 72? Maybe even 71, I would say.
Yeah, it's a bit.
I'm going to say 71.
Yeah, it's a bit lower and higher sometimes, but let's say 71, 72 on average, maybe.
Yeah. So
this is quite a big save in power consumption with the CPU light load, so with undervolting it basically, without losing any performance, even gaining a little bit of performance.
yeah, so I will show you this in the graph.
But whereas for the power limits, you can basically copy paste the settings I use, you cannot for this, because this really depends on how good your specific CPU is.
So if we check this in the overview, you see that I put CPU, this is the default for both. It's unlimited power, this is the score, the complete system wattage and the degrees Celsius. So now with CPU light load, we get a higher score, a bit higher. The system power usage is similar to a 200 watt power limit.
Yeah.
But there, if we do that approach for limiting power, you get an impact on CPU performance.
Yeah.
In Cinebench.
Indeed.
Temperatures are also around this level. I mean, 71, 68. So more performance, less power, higher efficiency.
Yeah.
Mike.
Yes.
So, and this you can still combine with the memory tuning we did before.
Yes, you can.
But at Cinebench, I think memory will not do a lot, right?
No, barely anything.
Yeah.
For certain games it does, other games it also doesn't. But as we saw, for example, Shadow of the Tomb Raider, we saw quite an increase. So you can indeed run a setting like this with the CPU light load, so you undervolt the CPU, get lower power consumption on the CPU, and you can use the performance mode for your memory. Then you basically have best of all worlds, I would say, in terms of performance.
Yeah.
So I've been showing this on a 14 gen, but in case you own a 12 gen or a 13 gen, you can also try this out. For the CPU light load, I would...
On MSI.
Yeah, the CPU light load, I would recommend only do it if you're comfortable with these kind of things. Because,
and step by step.
Yeah, it is a bit of trial and error. So at a certain point, you will get a blue screen and you will notice that your CPU cannot reach a certain level anymore.
Yeah. And it's also possible that if you do it during the winter, it will be different than during the summer. Ambient temperature has also something to do with it.
Yeah, but for this it shouldn't make too much of a difference because temperature is not really the limiting factor anymore.
Yeah.
So that should be quite okay.
For the CPU light load, indeed.
Yeah. Power limiting is basically safe for everyone. It's a very, very simple way of basically just allowing it only to draw a certain amount of power. And as you could see, even on the 125 power limit in multi-threaded workloads, it's still, and also single-threaded because there you won't even reach that power limit, you still outperform the 13700K at stock.
Compare yellow to yellow.
Yeah. So I would say fine-tuning is definitely worth it with also 13th, but definitely also 14th gen Intel Core processors. Eric, shall we do one last giveaway and then call it a day?
Yes.
I'm gonna stop the loop here.
Draw winners. Okay, so last giveaway for today. Because we're going to see you next week again.
Well, not us, I think.
No. Last winner for today, who wins the Assassin's Creed Mirage game code, is Helgen.
Congratulations.
Congrats. Already late for you. Good job. Okay.
So next week.
Yeah, next week Peter is going to play Sonic Superstars, new game. I think it was released today, not sure.
Ooh,
I saw some some press release. Anyway, together with Mankit, I guess.
Yeah, I think so too.
Talking about the keyboard, the Viger GK 71LR. What is LR?
I don't
Low
know, I think
profile? No.
No, I think it's something with the switches, but I'm not entirely sure.
You have to
actually.
come back next week.
Yeah, we'll see next week.
Yeah. That was for us. I hope you had fun.
Yes.
I had fun doing this, Mike. Thank you. Next,
Good.
I hope I did a good job for you.
Yeah,
so next
it was
time you
okay.
can consider
you
me
were a
as the
decent
9th
assistant
option.
today, yeah. But next time I'll kick you out for route again for these kind of lives.
Yeah, I can imagine. Yeah.
But thanks for your help today, Eric.
Yeah, indeed. Thank you. Bye. Bye.
Thanks everyone.
everybody.
Bye bye.